Welcome to my channel. Today I'm going to solve Alberta Provincial Achievement Test 2019 for grade 9. Let's take a look at the question number 1. It says, what is the value of 2 to the power 3 times 2 to the power 0? So here we know that 2 to the power 3 is the same as 2 times 2 times 2. So we're going to have 2 and multiply it 3 times. So 2 times 2 times 2. And 2 to the power 0 is 1. So we have to know that anything to the power of 0 is 1. So it can be 2 to the power 0, it can be 3 to the power 0, a to the power 0, x to the power 0. That is always be equal to 1. So if you break it up, we get 2 times 2 times 2 times 2 to the power 0, that is 1. So it comes up to be 8. And they want the answer in the integer form, so 8 is going to be your answer. So in number 2, we have an expression in the fraction form and we have to evaluate the expression. So one thing we have to know, on the top we have 3 square whole to the power 4. So there can be two situations. One is 3 square whole to the power 4, 3 to the power 2 to the power 4. So the difference is this 3 square is in parentheses and this 3 square is not in parentheses. So here that means that this power 4 applies to the whole 3 square, whereas this power 4 applies to only 2. So how do we evaluate each of them? So here we can multiply 3 to the power 2 is 9 to the power 4, or we can just multiply 3 to the power 2 times 4, that is 2 times 4, that is 4 to the 8. So it's going to be ultimately 3 to the power 8, that is same as 9 to the power 4. But here, since we do not have the bracket, we cannot do that. So without the parentheses, it's a little bit different. So it's going to be 2 to the power 4, that is 16, and we are going to put the whole thing above 3. So the difference is when there is a parenthesis, we actually multiply the powers. When there is not a parenthesis, we use it as an exponent. So 2 to the power 4. So it's going to be 3 to the power 16. So here we are concerned about the parenthesis. So here we can just go old school, like 3 to the power 2, and we can just say that 3 to the power 2 times 4, that 4 to the 8, and we can say that 3 to the power 8. The easiest way to do is, here we have 3 square, right? 3 square 2 to the power 4 means that we have 3 square and we multiply 3 square 4 times. So it's going to be 3 square times 3 square times 3 square times 3 square. So if we break it up, we can write 3 square times 3 square times 3 square times 3 square, and on the bottom we have 3 times 3, that is actually 3 square. So we know that 3 times 3 is equal to 3 square, and here then we have 3 to the power 4. So we can get rid of one of the 3 squares from them, and on the top we are left it 3 square times 3 square times 3 square. So another thing to note is that here 3 square, here 3 is the base and 2 is the power of the base. So if the base is equal, suppose 3 square times 3 to the power of 3, if these two bases are equal, we can just take one base and then we can add the power. So it's going to be 3 to the power 5. So 4 square times 4 to the power 4 is going to be, since the base is equal, we can just take the base as common and we have to add the two powers. So 2 plus 4, that's going to be 4 to the power of 6. So similarly here, we can just keep 3 square and then we can use the common base 3 and we can just add the power, that is 2 plus 2, that comes out to be 4, and divided by 3 to the power 4. So we have there 3 to the power 4 and 3 to the power 4 gets cancelled out. So we have 3 3s are 9. So the answer is going to be 9, and they want in an integer form. It is 9. So let's take a look at number 3. In this equation, we have to solve for x. So our objective is to take all the x in one side and all the integers or constant in the other side. So whenever there is an equation like this, if you want to change the side, suppose we have a plus in front of d. If you want to take d on the other side of the equation, we have to, instead of plus, we have to write it as a minus d. And similarly, if an equation is like this, so if you want to take the d on the other side of the equation, we have to Since we know that there is a minus in front of d, we have to do a plus d equals to c. So let's do the same thing here. We have, let's take the x, 2x on this side and 1 on that side. So it's going to be x minus 2x equals to 2 minus 1. So we have minus x equals to 1. Then we can multiply both sides with minus 1 and we get x equals to minus 1. So the answer is going to be x equals to minus 1. And also you can very quickly check your answer. Just try to put the value of x in here. If you put x equals to minus 1, suppose here we put minus 1. So in this side, in the left hand side, we know minus 1 plus 1 is 0. And on the right hand side, if x equals to minus 1, this term becomes minus 2, and minus 2 plus 2 is also 0. So we can see that this equation satisfies at x equals to minus 1. So let's take a look at number 4. In simplest form, what is the value of this expression? So we can see we have a proper fraction here, a proper fraction here, and here we have a mixed fraction. So a proper fraction is when the denominator is greater than the numerator, and an improper fraction is when the numerator is greater than the denominator. And the mixed number is when you have a whole number and add it to a fraction. So whenever there is a mixed number, we can transfer it to improper fraction. So how do we transfer it to the improper fraction? First, we write the denominator here, and we have to multiply the whole number with the denominator, and we have to add 1 to it, the number that is in the numerator. So we are going to multiply 2 times 2, that is 2 times 2, and we are going to add the numerator to it. So we're just going to say plus 1. So that's going to be 2 to the 4, 2 times 2, 4 plus 1, 5 divided by 2. So which is an improper fraction. So let's try again here. Suppose we have something 4 whole 1 by 2. So what we do is we multiply 2 and 4 and then we add the result to the numerator. So on the denominator we write whatever is in the denominator and we multiply this 2 and 4. So it's going to be 4 times 2 and then we add the answer to 1. So it's going to be plus 1. It's going to be 2 in the denominator. 4 2 is 8 plus 1 9. So this is how we convert mixed fractions to improper fractions. And this is important because we cannot add a mixed fraction with a improper or a proper fraction. So now let's just convert it. 1 by 6 plus 1 by 3 plus, we do 2 times 2 is 4 plus 1 5. Our next step is to find the LCM of the denominators. So what is an LCM? LCM of a set of 2 or more numbers is the smallest number that is divisible by all of those numbers. So if you want to find the LCM of 6, 3, and 2, that is the denominators of these fractions, we have to find the smallest number that is divisible by all of these three numbers. Here, just by seeing, we can say that the smallest number that can be divisible by all these three numbers is 6, because we can divide 6 by 6, that is 6 ones are 6. We can divide 6 by 3, 3 twos are 6. We can also divide 6 by 2, that is 2 threes are 6. So the smallest number that is divisible by all these three numbers is 6. So in that case, we are going to write 6 in the denominator, and the top we write the numbers. First we write 1, that is the numerator, and we multiply it by 6 divided by 6, that is 1. Then we have a plus, then the denominator is 3. So if we multiply 6 by 3 we get 2. So we write this number and we multiply it by 2. Now the third one is 2 here, so if we divide 6 by 2, the answer comes out to be 3. So we write 5 here and we multiply by this answer 3. So finally we are going to get something like 1 times 1 1 plus 2 times 1 2 plus 5 times 3 is 15 and divided by 6. So it comes out to be 6, 15, 16, 17, and 1 is 18. So we know that 18 divided by 6 comes out to be 3. 6 3 is 18. So the answer is going to be 3. So this is the most important part here, which can be confusing. So I just recommend you can just go back to the video and just check how we did this part. So in this part we did nothing. We just first found the LCM, that is 6, and for the numerator we just put the numerator first and multiply with the answer what we get when we divide this 6 by 6, and here we multiply with the answer what we get with dividing 6 by 3, and here we multiply with the answer when we divide 6 by 2. So before we proceed with this one, we have to have two concepts here. One is the multiplication of fractions, another one is the multiplication of signs. So multiplication of sign is when you multiply a positive number with a positive number, you get a positive number. When you multiply a negative number with a negative number, you still get a positive number. When you multiply a negative number with a positive number, you get a negative number, and when you multiply a positive number with a negative number, you get a negative number. So this table is very important that we're going to use in this problem. So let's see, the first two are negative times negative. A negative number times a negative number. If you look at here, we get a negative number times a negative number is a positive number. So first, let's just write plus and we multiply these two numbers. So how do we multiply fractions? We just multiply the denominators and we multiply the numerators. So the denominators is 2, 2 3 is 6, and the numerator is 1 1 is 1, and obviously this number is positive because we are multiplying a negative number with a negative number. So now we have times 12. Now we don't have any problem because we are multiplying a positive number with a positive number. So we can just reduce the 12 to 2 because 6 2s are 12, and we can say 2 times 1 is 2, and this is in the integer form. So this is the answer. So the main thing to find from here is when we multiply two positive number, we get a positive number. We multiply two negative numbers, we still get a positive number. But a negative times positive and a positive times negative is always negative. So in this problem, we're going to solve for x and we are going to express our answer to the nearest tenth. So, so the nearest tenth is we're going to have one digit after the decimal. So we have to know what is the place value. Suppose we have a number like 6.54378. So here we know that this is the 10th place, this is the 100th place, this is the 1000th place, and so on. So if they want a value up to 10th, we have to go only one digit after the decimal. So we'll have to learn how to round. So if you want to round 6.54 to the nearest tenth, we're just gonna omit this one. We're gonna write 6.5. But if the number is 6.55, we are gonna write 6.6. We are gonna round it up one place. So it's gonna be 6.6. This is because the next number is 5 or greater than 5. So if you have anything called 6.54, we can write it as 6.5. If you have anything called 6.53, we can still write it as 6.5. But if you have 6.56 or 6.57, if this number is greater than 5, then we have to increase this by 1. So we have to write 6.6. Also here also, this is greater than 5. The next number is greater than 5. So we have to write here 6.6. So let's just find the value of x here. So we're just going to break it up. So it's 2 times x minus 2. So if we break it up, we have 2 times x, that is 2x. Then we are also going to do, so this is what we're going to do. We're going to do 2 times x, then we are going to minus and do 2 times 2. So this is going to be 2 times x minus 2 times 2 is 4. That is equal to, we're just going to keep it as it is, 4x minus 13. So I know we can do a lot of things, like we can add stuff, 13 to both sides just to eliminate this 13. We can add minus 4 to both sides to eliminate this 4x. But the easiest way to is to do change the side. So if I change the side, it's going to be 2x, and I'm going to take all the x's in one side. So it's going to be 2x minus 4x, because I'm taking this positive 4x to this side. As a result, it becomes a negative 4x. And then we have minus 13 on this side is fine, but now we have minus 4 on this side, and we're going to take it on this side. So it's going to be plus 4. So the bottom line is when we change sides, the sign changes. So here we have 2x minus 4x, that is minus 2x, and we have minus 13 plus 4, that is so that's going to be minus 9. So now we are just going to multiply both sides with minus 1, so we get 2x equals to 9. Therefore x is going to be equal to 4.5. So we have 4.5. So here we already have, they want it in nearest tenth. So we already have it in nearest tenth because this is up to one decimal place. But if they want if they want it up to two decimal place, so can we make it a two decimal place because there is no number after one? We actually can. We are just gonna supposed to put a zero after that. So no matter how many zeros we put at the end after a decimal, the value is always the same. We can add many zeros, that is still be equal to 4.5. So if it is asked to find up to two decimal places, don't be confused. Just put a zero and make it two decimal place. If it is asked to find three decimal places, you can put two zeros and make it a three decimal place. So let's take a look at number 7. Say solve for x in the following equation. So whenever we have something like this, a number multiplied to a sub expression in a parenthesis, we have to distribute it. So if it is something like a times c plus b, what we do is we multiply a and c, and then we give this plus here, then we multiply a by b. So this is called distribution. So here we're going to do the same thing. So 2x equals to minus 4 times 1 by 4, and then we have a minus here, and then now we have minus 4 times 3x by 4, and in the end we have a plus 4. So we have 2x equals to, this 4 gets cancelled out, we have minus 1, and again we have minus times minus 4, so minus and minus we have plus, so it's going to be plus this 4 and this 4 gets cancelled out, 3x plus 4. Now if you take 3x on this side, we have minus x equals to 4 minus 1, that is 3. Now we are going to multiply both sides with minus 1 so that we can get rid of minus here. So we have x equals to minus 3. So the answer is going to be x equals to minus 3. So you have to make sure that you don't have make any careless mistake here, because these there are a lot of small calculation and it is very easy to make careless mistakes here. So the thing that we learn here is that we have to distribute this. Whenever a number is multiplied to an expression, suppose 4x plus 5 or anything like this, we have to distribute it. So we distribute like this: 4 4s are 16x plus 4 5s are 20. So this representation is called a factorized representation. So this is a factor representation. This is a factor and this is a factor. A factor representation A factor representation is a form of product of two terms. So here 4 is a term and 4x plus 5 is a term. So this is in the factor representation. If you want to simplify it, we have to distribute it. So that is 4 4 is 16x plus 4 5 is 20. So let's take a look at number 8. We are just gonna find the value of this expression here. So here are points. So what do we usually do when we have a number like when we have 2 plus 4 plus 5, we can stack them up like this: 2 plus 4 plus 5. And when we have decimal numbers, we can stack them up, but our main objective will be to align the decimals. So we have to align the decimals. So here we have 13.2, and we will have to align all the decimals here. So we have three numbers. We are going to align the decimals. Just put this decimal here and put another decimal here. So for 0.05, we are going to write um, 0.05. So we cannot actually always align the numbers because here is 2 and here is 0 and 5. So we have to make sure that you are aligning the decimal. So we have 5.45, so it's going to go 5.45. So in decimal, instead of aligning the number, if you align the number, which would be wrong, and which would look something like this: 0.05 plus 5.45. So this would be wrong because we cannot add it by aligning like this, because this two decimal is aligned, but this decimal is not aligned with the other two. So we have to make sure that instead of aligning the numbers, we have to align the decimals. So now we can add them. If we add them, we know that here is a 0. So we have 5 plus 5, that is 10. We have 4, 5, 6, 7. And that is the reason we align the decimal, so that we know where the decimal is. The decimal is going to be here. And 5 plus 3 is 8 and 1. So it's going to be 18.70, or we can just write 18.7. So here we are going to in number. Let's take a look at number 9 here. It is evaluate this and express your answer as a decimal. So here we are going to use a concept called BODMAS. So this is the order we are going to proceed in a calculation. So B stands for brackets, or we can also say parenthesis. O stands for or, D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. So this is the order. First we have to do whatever is in the bracket, and then we have to do the or it is off, actually off. So then we divide, then we do the multiplication, then we do add and subtract. So off is a lot like multiplication. We can say that we have in a certain number of 10 we are concerned with, suppose 2/5 of 10. We can say what is 2/5 of 10. We can just say that we, in that case, we just actually gonna multiply this. We say 2, 5 2s are 10, 2 2s are 4. So 2/5 of 10 is 4. So this is what off is all about. So let's take a look here. We have 2 plus 2 times 5. So here in the list, we can see that multiplication comes before addition. So we have to do the multiplication first. We have 2 plus, we do the multiplication first. 5 2s are 10 whole to the power 2. And in here, we do bracket first because bracket is on the top. So here we have 2 times 4 5s are 20. So we actually have 2 times 20 is 40. And just so you know that when there is no sign, that means it's a multiplication. And there here on the top we have 12 to the power 2, that is 12 square. So here we have 12 times 12, and on the bottom we have 40. So we are just gonna do 4 3s are 12, 4 10s are 40. So it's basically 12 3s are 36 divided by 10. So the answer is gonna be 3.6. So in this math, this is very important to memorize that BODMAS. We have to do bracket first, then off, then division, multiplication, addition, and subtraction. So in number 10, we have to order these numbers from smallest to greatest. So usually in a fraction, if you want to know that which fraction is the biggest, what we do, or which fraction is the smallest, or which fraction is the bigger than the other, what we do is we equate the denominator. So suppose we have 3 by 4 and 5 by 8. Okay, and we want to know which fraction is the uh, bigger fraction here. So in order to do that, we are gonna equate our denominator. So here the denominator is 8, so equate the denominator. We have to multiply this by 2. So we have to multiply 4 by 2, we get 8. And of course in a fraction, if we multiply by 2 by anything on the denominator, we have to multiply the same number on the numerator. So it's gonna be, this fraction is gonna be 8 6 divided by 8. So now we have 6 divided by 8 and we have 5 divided by 8. So this is, so this means 6 portions out of 8, and this means 5 portions out of 8. So obviously this is bigger. So the thing is, whenever the two denominators are equal, the fraction with the greatest numerator is the bigger one. So if it is 7 by 8 and we have 3 by 8, this is the bigger number here. So another way to do this, we can convert this to decimal, and we can also convert this to decimal, and then we can say which one is bigger. So here in this math, we are going to try to convert them to decimal because we have a bar here, 0.75 bar, that we do not want to convert into fraction. So 0.75 bar means it's 0.75, and the bar is on 5, right? So whichever number has the bar, that number keeps repeating infinitely. So this is gonna be, so basically this is what they want to say is 0.7555. So if we round it up, suppose if you want to round it to like two decimal places, we can say 0.76, because here is a 5. When we have a 5 on the next number, anything 5 or greater than 5, the previous number we increase by 1, so it's going to be 0.76. So this one actually transfer to 0.76. Here we have root over of 9 divided by 25, that is the same as root 9 by root 25. So because we can distribute the root in a fraction, and that's going to be 3 by 5. And here we have 3 by 4. Here we have 0.7 squared, that is 7 sevens are 49, and that's going to be 0.49. And this is 0.75 bar, and that's more or less 0.76. So we have an idea about these two numbers, but these are fractions. Let's convert them to decimal. So we have uh, 3 divided by 5. So if we divide it, we have a point here, then we add a 0, we have 5, 6 30. So this one is going to be equals to 0.6. And if we divide 3 by 4, we give a point here, you have a 0, that 4 7s are 28. Then we have a 2 here, and see, since we have already given a point, we do not have to add any more points. We can just bring a 0 here. So it's going to be 4 5 is 20. So this is going to be something like 0.75. We already know this is 0.49, and this is point, if you round it, it gets something close to 0.76. So now we can easily say that point here 0.49 is the smallest because it's zero point 0.4, so it's going to be point. So we are going to write as, so this is actually 0.6, this is 0.75, this is 0.49, and we can write it as 0.76. So the order is going to be the smallest one first, 0.49, comma, then we have 0.6, then we have 0.75, and last but not the least, 0.76. So this is going to be the order. So if you want to write the numbers as given in the question, we have to write first 0.7 square, then which is 0.6, which is same as this one, root 9 by 25. Then we have 0.75, that is 3 by 4, and we have 0.76, that is 0.75 bar. So this is going to be the order. So this was the first part of my solution, question 1 to 10. And in the next part, in the next video, I'm going to do the last part, that is question 11 to 20.